Hi there. I wanted to show you a few tricky things that AP might kind of show you. They're just three little ideas. So it says in this problem, I want to bring you to three different problems. Which ground state atom has an electron configuration described by the following orbital diagram? My point of this is just to show you a different way that they might show these things. This is kind of an Aufbau diagram, an orbital diagram, and it just shows that it goes neon, then it's got 3s2 and 3p3. So if I go on the periodic table, I'm going to look for neon, and then past that it goes 3s2, 3s2, 3p3, 1, 2, 3. So it's showing us phosphorus. So this one is phosphorus. Not too tricky. Let's go to the next one. Which of these choices is electron configuration of an excited state oxygen? Okay, so that's when I probably want to think to myself, what's normal oxygen look like? If I look on the periodic table, it's going to be 1s2, 2s2, 2p4. That's normal ground state oxygen. But I'm not looking for ground state oxygen. Ground state oxygen is right here. And I'm looking for the excited state, so this is not a good answer. If I look at this next one, it goes 1s2, 2s, it's got the 5 there. Well, the 5 would mean it either is an ion, oxygen as an ion, that's a 1 minus ion, or it's a completely different atom. That is not what I'm looking for. This one here, it goes 1s2, 2s2, 2p3, and normally it should go 4 there, but I can see one electron is now in this 3s area. This right here is your excited state 1. So C is the correct answer. An excited state 1 is you just take an electron, and you can take it out of this one, or this one. You take an electron out of somewhere, and you put it somewhere further out. So another kind of excited state is I could actually take this one out right here and make this a 1. And I could put the electron into 4f1. I can put it anywhere I want. It's just an electron in a different spot. You take it out of one spot and you put it in another. You don't necessarily have to take it out of that outer spot. Lots of times I do, but you don't have to. Let's take a look at this bottom one here. This D1, they've added 2 electrons, which is commonly what the oxygen 2 minus ion would be. So that would be what that one is. And then down here, I can see that they lost electrons. So that's an oxygen as a 1 plus. It lost electron. Not likely to be an oxygen with 1 plus, but always possible. Looking at the next part, I guess I got 2 parts. Selenium electron configuration is, if you look at this one, it's kind of weird, right? Do we normally put 3D instead of in the front of 4s? No, we normally don't. My point with this one is sometimes they do just because they do. I just want you to see it and be aware of it. What would I do if I were you for writing an answer? Put 4s in front of it. When we get to photoelectron spectroscopy, PES, we'll talk more about why they might put it in this order or not. What we want to do is put it in the lowest energy to the highest energy. And lowest energy is most often that 4s first. So if I was going to do an answer, I'd always do 4s2, then 3d10, like we've always been practicing. And you can't go wrong. How many unpaired electrons does sulfur have? Or any kind of question about unpaired electrons. That's when I would write it out for sulfur. Sulfur would be 1s2, 2s2, 2p6, 3s2, 3p4. Okay, the unpaired electrons are only going to happen in the end, so 3p4. And then I want to say, how many orbitals does p have? P has 3 different shapes, so it has 1, 2, 3. 3 lines to it. There are 3 orbitals, 3p orbitals. And so if I need to put 4 of them in there, I go 1, 2, 3, 4. Only if you think of it in this way can you remember or see how many unpaired electrons there are. Otherwise, when you look at the 4, you're not quite thinking right. You're thinking 4, okay, 2 and 2 is 4, but you're not seeing the picture that there are 3 orbitals. We put 1 electron in there by themselves first and then start doubling up. So that's why sulfur has only 2 unpaired electrons. So my tip there is always write these last little orbital diagrams. And that should save you. Good luck.